Welcome to qnawire.
We have a rocket that's launched, and here's its height, and we have 4.9, and so this is because the acceleration due to gravity, and all these constants we have here, and this means that's actually the initial height that this is launched from, and this is all in terms of meters. So we input time in seconds, and we output the height of the rocket in meters. And the first thing you wanted to know is when will it hit the water? And so we want to find at what time it will end up being at a height of 0. So if we set this equal to 0 and use quadratic formula, we know our time is equal to negative 241 plus or minus the square root of 241 squared minus 4 times a, which is negative 4.9, times c, which is that 136, and that's all over 2 times a, which will be negative 9.8. And so I haven't calculated this before, so we'll do this now and find the discriminant first. 241 squared minus 4 times negative 4.9 times 136. And this value, and then I'm going to square root it. Whoops, I have to clear that out. Square root it, take it to the 0.5 power. And so this value comes to be negative 241 plus or minus, and it comes out to be 246.468 approximately. And I'm just going to store that value in my calculator. I'm just going to call it A, and then over negative 9.8. And we know that the picture is it's going to start from a height, it's going to go up and come down. So we're going to get two zeros. We're going to get one that's negative and one that's positive. And so we don't want to calculate if we take this plus this, that will give us a positive answer divided by a negative. So we actually want to find this one. So if I take the negative, left parenthesis, negative 241, and then subtract away that value I just stored, and then divide that by negative 9.8, I find that my time is after 49.74 seconds. That's how long it's going to take before it finally hits that ground here. So there's my first time. Now you also asked what will be its peak height? And we know its peak height is going to take place at the vertex. And the vertex, remember, is going to take place, the vertex, x-coordinate of the vertex, is going to take place at negative b over 2a. So the x-coordinate is going to be negative 241 over 2 times this number, which is negative 9.8, or that is the vertex. Okay, and so if I take the negative 241 divided by the negative 9.8, I end up getting that the time where it's going to end up being, and that should be a t value, the time where it's going to be at its maximum is 24.59 roughly seconds. That's the time that it's going to end up being at this maximum height. And so now I just need to go to my model and let's plug it in. If we plug in that negative 4.9, and then we put our t squared plus the 241t plus that 136, isn't it? And the way I'm going to do this is I'm going to store this value so I don't have to. I'm going to hit store. I'm going to call it A, or you call it X, and then I'm just going to plug in negative 4.9 times alpha A squared, and then do plus 241 times alpha A, and then plus 136. So I'm not actually going to be plugging in that number. And I find out that that height that it's going to be at is very high, 3,099.3 meters above the water. So here is how long it's going to take before it hits the water. This is the time at which it will be at that maximum height in the air, almost 25 seconds, and it's going to be at a height of close to 3,100 meters.